Alright guys, here is 9-1 monomials and factoring. So you will find the greatest common factor of a set of whole numbers, and we will factor a monomial from a polynomial. So here's some vocab. Whenever you have something that is in factored form, this is when a monomial is written as a complete list of its prime factors. You may also see it called prime factorization. So for our first example, it says monomial in factored form tells us to factor negative 20 x cubed y squared completely. So you can, first of all, you have to factor out this negative. So to do that, it becomes a negative 1. And then I list out, so I've got negative 1 times 20 x cubed y squared. And then I can take my 20 and use a factor tree, and then I get 2 and 10, which gives me 5 and 2. So I got 2 times 10, which factors into 2 times 2 times 5. So that is my coefficient in factored form, and then I expand my exponents. So x cubed, I have x times x times x, and then y squared, I have y times y. So the factored form for this monomial is negative 1 times 2 times 2 times 5 times x times x times x times y times y. That is in complete factored form. So go ahead, pause the video, and solve both your turns. Once you are finished, you can hit play and you will see the answer. I'll work it out here. So 34 can be factored into 2 times 17. 17 is a prime number, so I can't go any further. So I got 2 times 17 times 4 x's times 3 y's. And that is my monomial in factored form. And for negative 52, a squared b, I first have to separate the negative, a squared times b. So now 52, I can factor into 2 times, what is 52 divided by 2? Do that quickly. 2 times 26, and then I can turn this into 2 times 13. So this becomes negative 1 times 2 times 2 times 13 times a times a times b. So that is my my monomial in factored form. So now example 2 says find the GCF of two monomials. There's two methods that you can use. The first method is factored form, where you write each monomial in factored form. So 12 I can factor into 6 and 2, which gives me 3 times 2 times 2. And then I list out my A's, B's, and my C. And then for my 18, this is 2 times 9. 9 turns into 3 times 3. So I list out my two monomials in factored form, and I circle the common prime factors. So they have a 2 in common, they have a 3 in common, they have 1 A in common, 2 B's in common, and the second monomial has no C, so that's all they have in common. So the GCF, I'm going to multiply them all together, 2 times 3 times A times B, which equals 6AB squared. As my, the GCF of those two monomials. The second method is called the shelf method. I teach it to my 7th graders as the ladder method. So, first thing you do is you write your monomials on a shelf and then you factor out the GCF of the coefficients. So I have 12 and 18. The smallest number that goes into both of those, well, actually they do it a little bit different here. So 6 is my greatest common factor of 12 and 18. And then after I do that, I'm left with just 2a squared b squared times c, and then 3ab squared. So I look at the first variable and I factor out the number of that variable that they have in common. So the first variable is a. They have only one a in common. And then I continue until the GCF is 1. So then there's 2 b's in common. So I factor those out and I'm left with 2ac and 3. So I then multiply on the side and I get 6 times a times b squared, which gives me the same answer as 6ab squared. Either method that you like is totally fine. That's why we show you both methods. So now, go ahead and pause the video. I will work out your turn so you can check yourself. So go ahead and hit pause and work out all 3 of your turns. So, 6xy cubed, 18yz. Here, I'm going to pull out a 6, and then I'm left with xy cubed y squared. Oops, no, that's a z. So it's important to... Next, I'm going to start with my first variable listed. There is no x, so I can't pull out an x, but I can pull out one y. And then I'm left with y squared times x, and then just a z. There is no z there. So, my GCF is just 1. So the GCF of this one ends up being 6y. So that's using the ladder method. The second method, or the second one, I'm just going to use the prime factorization. So 11a squared times b can be factored into 11 times a times a times b. 21ab squared can be factored into 3 times 7 times a times b times b. I'm going to circle what they have in common. They both have 1a, and they both have just 1b. So the GCF of this ends up being AB. Last one here is a little bit longer, so you will have a longer prime factorization list. So 30 q to the third r squared times t. We've got 2 times 15. 15 is 3 times 5, so it's going to be 2 times 3 times 5 times q times q times q times r times t. It's a long list. And then 50 q squared rt is going to be, so I got 2 times 25, which turns into 5 times 5 times q times r times t. Now I'm going to circle everything they have in common, and they have a 2 in common, they have a 5 in common, they have 1 q, 2 q's, 1 r, and 1 t. So the GCF here is going to be 2 times 5 times q times r times t, which gives me 10 q squared rt. So I've used prime factorization to get a GCF. So now, using the distributive property to factor polynomials. To do this, you are going to find the GCF, you write it on the outside of the parentheses, and then you write what is left in each term inside the parentheses. So you write leftover inside your parentheses. So what it looks like here, there's two methods. Once again, you've got your factored form and your shelf method. So my factored form, I've taken negative 4a squared times b and written out the prime factorization. I have done that for all three monomials, and then I start circling what they have in common. So here, they all have a 2, they all have 1a, and they all have 1b. So my GCF is 2ab. So for the distributed property to factor your polynomials, I'm going to write the GCF on the outside, and then I'm going to write what is left over. So when I take away 2ab from my first term, I'm left with negative 2. When I'm taking 2ab away from my second term, I'm left with negative 4b. And then the last term, I take away 2ab, and all I'm left with is just a 1. So that's using the distributive property. The shelf method or the ladder method I prefer because at the end of the method, you are left with a factored form. To me, this works out just a little bit faster. That's why I teach my kids in the 7th grade the ladder method, just because in the end, you do get the factored form. So, I'm taking out my 2, which is my GCF, and then I'm left with the next row. So I start out with a since it's my first variable, and I take away 1a from all three terms. Then I go to b, and there's only 1b in all three terms. So I take away that, and I'm left with 2 times a times b, which gives you my GCF, and I write it on the outside. And then look, here is my factored form. So that's why I prefer the ladder method, but it really is totally up to you which one you choose. Excuse me. So for this one, I've got 15w minus 3v. Notice there is no common variable. So for this one, I'm just going to take away 3, and then I have 5w minus v. So I write my GCF on the outside, and I'm left with 5w minus v. I factored that polynomial. For this one, it's a little bit more difficult just because there are multiple variables. So here can be my first part of my ladder. There is no common coefficient besides 1, so it doesn't really help us. Kind of a useless step. 7u squared t squared 21ut squared negative ut. So now I'm going to pull out my first variable, which is a u. There is at least one u in all of my terms, in all three of my terms. So when I pull that out, I am left with this one right here. And then I've got 7u t squared, 21t squared, and then negative t. Now I'm going to pull out 1t, so I'm left with 7ut, 21t squared, and negative 1. I'm at the point where my GCF is going to be 1, so I can write ut, and then I'm left with 7ut plus 21t squared minus 1. To check myself, I can always multiply out. The zero product property tells us that if the product of two factors is 0, then at least one of the factors must be equal to 0. You want to make sure that your equation is set equal to 0. That is important. So make sure your equation is equal to 0 on one side. So, solve equations. Solve each equation. You want to check your solution. So, this one gets set equal to 0, and then this one also gets set equal to 0. So, I got 2d plus 6 equals 0. Notice, it's just a two-step equation. I subtract 6 and then divide by 2. For my other solution, I've got 3d minus 15. I add 15 and divide by 3. And I get something called roots. Roots are solutions to these kinds of problems. There are 2 of them. You can have 2 of them. You can have 1, and you can also have 0. There is a way to check. Notice this little symbol right here, kind of like a question mark above equals. You don't know that it equals 0 until the very end. And if it doesn't equal 0, you know you have solved something incorrectly. So what you do here, use your zero product property, and you make both factors equal to 0 and solve them. And then I've got c squared is equal to 3c. First step is to make it equal to 0. And so now I am going to think about what c squared minus 3c should look like. So if I want to use, so I got c times c, and then 3 times c. C is my GCF, so it's going to be c times, I'm left with c minus 3 is equal to 0. So c can either equal 0 or c minus 3 equals 0, so c is equal to positive 3. So my roots are 0 and 3. If I want to check, if I go, so 0 times c minus 3 is equal to 0. Anything times 0 is equal to 0. Wait a second. So then I also have c minus 3. If I have 0 minus, if I have 3 minus 3, does that equal 0? And the answer is yes, 0 does equal 0. So we have done it correctly. Here are 3 your turns. So I'm going to just put the answers instead of working them out. Notice that this one should be, go ahead and pause it and then come back and check and see if you've done it correctly. So this can be split up into 3n is equal to 0 or n plus 2 equals 0. So my roots, n equals 0 and n equals negative 2. Over here, I have to factor first. So I can pull out an 8b, and I've got b minus 5b. Oops. Just b minus 5. And that's going to equal 0. This can turn into 8b is equal to 0, or b minus 5 equal to 0. So b can be 0, or b can be positive 5. Last one, I have to set it equal to 0 first. Is that being x squared plus 10x is equal to 0. Pull out an x, and I have x plus 10 is equal to 0. X should equal 0. And then x plus 10 should equal 0. X equals negative 10. Or x equals 0. And you can check those if you are uncertain. So there is factoring monomials using prime factorization and the GCF in 2 different forms. If you have any questions, make sure you email one of your teachers. And hope you guys know that we miss you.